So in this video we're going to discuss dimensional analysis, otherwise known as unit conversions. So before we get started, let's make some real world unit conversions that you're probably already familiar with. Like number one here, it says how many quarters are in $10.75. So you're going to have to know how many quarters in a dollar to answer that. Similarly for number two, talking about spiders. If you don't know how many legs each spider has, you can't answer that. Same thing with chocolate wafers on an ice cream sandwich. Same thing with number of yards in a football field. So those are just things you need to know in order to answer it. So for quarters, if there's 4 quarters in a dollar, then 4 times 10.75 is 43 quarters. Or you could think 4 times $10 is 40 plus 3 more for 75 cents. Every spider has 8 legs, so 3 of them, 8 times 3 is 24. So again, we're multiplying. Every ice cream sandwich has 2 wafers. If there's 6 sandwiches, then that's 12 wafers. We're multiplying. And if you said 100 yards in a football field, then that would be 700 yards. Some people count the end zones, whatever. So the whole reason for doing this is that sometimes measurements are too big or too small for one unit. Like there's no point in keeping something in centimeters if you need a bigger unit. Sometimes an equation needs a specific unit. So if you don't use that the correct unit in the equation, you're not going to get the right answer. So that's important. And we're going to use this all the time in labs because sometimes it makes sense to measure something in a small unit like centimeters, but it needs to be in meters, so we'll have to convert it afterwards. There's a whole bunch of metric prefixes we need to talk about. One is milli, which means 1,000th or 0.001. And common words with this prefix like millennium or millipede or millimeter or millisecond. A millisecond is 1,000th of a second. A millennium is 1,000 years. So this prefix usually deals with the number 1,000 in some way. Centi means 100th or 0.01 or 1 over 100. And common words that use this are century, like 100 years. A cent, which is 100th of a dollar. Centennial is 100 years. Kilo means 1,000, not 1,000th like milli, but a bigger number. So it means 1,000 of something, like a kilogram or a kilometer, meaning 1,000 meters or 1,000 grams. And there's a whole bunch of other ones that we're going to use less often, but we're going to use centi and kilo quite a bit, like micro, giga, and mega. Micro means 1 millionth, or 1 over a million. Giga means 1 billion, so 10 to the 9th, and mega means a million, which is 10 to the 6th. So things like kilo and mega and giga, those are big prefixes, meaning they take the base unit and make it bigger. Like a kilogram is 1,000 grams. Centi and milli are smaller ones, so they're making the base smaller. So if you think of the base units as gram, meters, liters, and seconds, we're not going to deal with liters, but that's the base SI unit for volume. Adding a prefix just changes its value or its meaning. Like adding a kilo in front of gram makes it 1,000 grams. Centimeters are smaller than meters, so it takes more of them to make 1 meter. Millimeters are even smaller, so it takes even more of them to make 1 meter. And these same rules apply to any unit, like milli, centi, kilo. You put it in front of anything and it changes its value. So we're going to use that shortly. Then we're going to make a T-chart, which just looks like a big T, or a T with a really long middle part. We're going to take what we're starting with and put it in the top left corner up here. So in this case, we're starting with 2 meters, so that's what I put up there. That's step 3. Step 4 is to pick the conversion factor and put it in this right part of the chart so that the top part cancels out, because we want to get rid of meters. So in order to cancel, it needs to be at the bottom. So we're going to take the 1 meter part and put it in the bottom, and then put the 100 centimeters at the top. Notice that whatever's on top of something, like 100 centimeters is on top of 1 meter, they are an equivalent value. 100 centimeters is 1 meter. That's always going to be true. You always need a vertical agreement going on. Alright, so now that we put in our conversion, step 5 is to cancel any units that are on top and on bottom. So the meters is on top and bottom, so those get crossed off, they're gone. And we're going to circle what we're left with, which in this case is centimeters. Step 6 is to multiply across the top, so we have 2 times 100, which equals 200, then multiply across the bottom. In this case we only have one number down there, but it is possible in other problems that you will have multiple numbers in the bottom. So you multiply those together and bring the answer over here. So we have 200 divided by 1. Then the last step is to divide and add the unit that we're left with. So 200 over 1 is 200. Then we're going to bring that centimeters from up here and drag it down here. So now we successfully showed to convert from 2 meters to 200 centimeters. This was a simple example.
Alright, so now let's try some harder examples. So for these, I'm actually going to write on a sheet of paper. Hopefully this works well. Alright, so for the first example, I'm going to do 93,000 millimeters, and I want to know how many kilometers that is. So this is what I call a two-step problem, because I can go from millimeters to meters, but that doesn't get me to kilometers, so I'll have to go from meters then to kilometers. So I have to do two T-charts. But you don't have to do them separately, you can put them in the same chart. But we'll do the first thing of writing down what we know. We know 1,000 millimeters is equal to 1 meter. And we know that 1,000 meters is 1 kilometer. So there's my conversion factors. So now, I'm going to set up my T-chart. I'm just going to start simple. I need to put the number I'm starting with in the top left corner. So I'll put 93,000 millimeters. It's important to make sure you put the units in the chart. The whole point of this chart is to convert the units. So if you leave the units out of the chart, what's the point of doing the chart in the first place? Now, what unit has to go down here to cancel up there? That would be the same unit. So I'm going to take this factor and put it here. 1,000 millimeters. Then what's on top of that always has to be equivalent, so I'll put 1 meter. Now I'll have millimeters and millimeters, and those will cancel. And I'm left with meters, but I want kilometers. So instead of finishing this and multiplying and all that stuff, I'm just going to add another section of the chart and keep going. I want to cancel meters, so I know the unit down here will be meters. And I know that 1,000 meters is 1 kilometer. So I'll put the 1,000 here and 1 kilometer up top. The meters cancel. I'm left with kilometers, which is what I want. Now I'm ready to multiply across the top and multiply across the bottom. Up top I'll have 93,000 times 1 times 1 divided by 1,000 times 1,000. So in other words, 93,000 millimeters will equal, it's calculator time, 93,000 times 1 times 1 divided by 1,000 times 1,000. And I'll get 0.093 kilometers. I always like to box in my answers. Hopefully the calculator shows up clear on the video. Looks like it. So let's double check. We have 93,000 up top divided by 1,000 times 1,000, which is what's in bottom. All right, should be good. Now let's try an even harder, trickier question. So now I'm going to say, what if we had 70 miles per hour, and we want to know how many meters per second that is. This is the standard English unit, or what we use here in the United States for speed. But in physics, we're going to use meters per second as a standard unit. So this will be a common conversion that we'll have to do from what we're used to what we need to use. So this one's going to be a little bit longer process. So I do know that there's 1,609 meters in 1 mile. Now if you run track or cross country, Your coach might tell you there's 1,600 meters in a mile. Technically, it's a little bit more. It's 1,609 meters. So I can go from meters to miles with that information. But then I need to know hours to seconds. So I need to change both these units. I do know that there's 60 minutes in 1 hour, and I know there's 60 seconds in 1 minute. So I'll have to go from hours to minutes, then minutes to seconds. So I'm going to have to do 3 steps in this chart. Let's get started. So I have 70 miles, and here's where it's different. When you have 2 units like this, that bottom left box is where you put the bottom unit. So 70 miles per hour. Okay. And you have to decide when doing one of these with multiple units like this, which unit to deal with first. Let's go with the top. So I'm going to start with miles. And now I need to put miles down here to cancel up there. So I'm going to put 1 mile, and then up top will be 1,609 meters. The miles cancel, but I still have, oh wait, no, I have meters up top. That's what I want. So I'm done with the top unit. Now I need to deal with the bottom unit. I know from over here that there's 60 minutes in 1 hour. I don't want to put hour down here though, because that won't cancel. It's already at the bottom, so I need to put it up top this time. So I know that 1 hour is 60 minutes. Now those answers will cancel, or the hours will cancel. I only have minutes in the bottom, so I need to get seconds. So I'm going to put 1 minute up top, 60 seconds in the bottom. The minutes will cancel. Now I'll have seconds on the bottom, which is what I want. So now it's time to multiply everything and divide. So in the top I'll have 70 times 1,609. And I'm leaving out the ones this time, because multiplying by 1 doesn't do anything. And then I have 60 times 60 in the bottom. Let's get the calculator out. That was 70 times 1,609 divided by 60 times 60. That gives me 31.3 about meters per second.
Okay, who's gonna go first?
Okay. So I hope that helps you with all the examples in the assignment. You can feel free to message me on Edmodo if you have any questions. Thanks for watching.